Bonjour, welcome to Wahsa Citizen Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 till 11 in the morning. And we are wrapping up our second week of our 9-week course. At this point, you should be thinking about what work you need to be submitting. We have finished chapter 1 and are partway through chapter 2. So we're already moving forward. Remember that the key questions are listed at the end of each of your IL lessons, and you need to do all of them. You need to do the check your understanding questions, the activities, and the review questions as they are listed. You're not doing all of them in the book, so make sure that you're looking at the list. Explain your ideas and your thoughts in complete sentences. Don't just give me point form or one-word answers, give me full thoughts, and make sure you're actually answering the question. You can do this by hand or electronically. I'm fine with either. If you want to, you can write in your workbook. It is yours, but those spaces are really small, so I'd encourage you to write them on a separate piece of paper to give me your full thoughts. If you want to do it electronically, Word and Google Doc files are the ones that are easiest for me to access. Everyone has access to Google Docs through their NNEC email address. So if you need support to figure out how to do that, let me know and I can walk you through it. If you need to use a different file type because that's what you do, that's probably fine. Just let me know so that I can make sure I can open your files. Okay, so then how do you actually submit your work for marking? So the first method is to send your work in electronically. You can scan your work if you've done it by hand. If you have an Apple device, the Notes app that comes with it has a scan function. If you have an Android device, then the Google Drive app, which usually comes with those devices, also has a scan function. They're both fairly straightforward. Again, if you need me to support you, let me know and I can help you do that. If that doesn't work for you and you'd prefer to just take a picture, that's totally fine. The files are just a little bit bigger and a little bit more awkward, but we can definitely make that work. Then you can send it to me either through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can also send it to me through Facebook Messenger, which you would send it to me at bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. Unfortunately, we are not yet open to the public, but if you drop it off in that mailbox, I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslatewahsa. So friend me on Facebook and subscribe to my YouTube channel. Every radio Zoom class is recorded and then I post it shortly after airing onto YouTube under a playlist called SVN3E. And I share that on Facebook. So it's a really easy way to connect to our lessons that as a replays if you've missed them or if you want to go over something again. I also have all of our supplementary videos that are on YouTube connected there on a playlist. So you can find them from the original sources if you'd like. Science is a really visual subject. I do my best to integrate as many videos and diagrams, charts, graphics as possible to make it more interesting and also to really help you understand. So I strongly encourage you to access the videos either live through Zoom or through YouTube. If you can't do that, if you don't have reliable internet and it doesn't work, let me know and I can send you a copy of the recording so that you still get the full experience. All right, if you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. You can call me at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 till 11 in the morning, so you can't get a hold of me then. If that doesn't work for you, let me know and we can try to connect outside of those hours. All right, I think it's really important to position myself within the context of this course, as my experience as an educator and as a learner shapes how I teach this course. I have white settler ancestry, I have white privilege, and this definitely has made my learning experience, my education experience, easier than those who do not have white privilege. I recognize that, and I'm working to disrupt those patterns to continue to be on the journey of being an anti-oppressive educator. I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and respect that culture and hope to integrate it as much as I can within this course. It is something that is a bit challenging, as I have no real previous experience, but it's something that I'm committed to doing. As an educator, I have lots to learn and to unlearn. And so this is not a perfect course, and I welcome feedback about how I can improve and how to make it more inclusive and more representative of our students. Our textbook is also Eurocentric. It ignores Indigenous, Inuit, and Métis knowledges and experiences, and this I find highly problematic. I've been looking for an alternative resource and I've yet to find one. If anyone has any suggestions about environmental science that would be more applicable to and recognize the perspectives of Indigenous, Inuit, and Métis peoples, I would super appreciate that and work to make that happen. All right, so today's lesson is a Throwback Thursday lesson. We are going to review what we have done already, which are lesson 1 through 5. So let's dive in. You may be asking, why are we reviewing already? It's only the second week. This is only our 7th class. So we've only had 5 actual lessons that are questions that you can be submitting to for grading. But research done by Herman Ebbinghaus in 1885, which has then been expanded upon over the last couple centuries, has shown us that we forget information really, really quickly. So if we learn something to the 100%, we understand it completely on the day that we learn it. By the next day, we've already forgotten 20% of that information. We've already lost that and only retain 80%. By 2 days after learning that, now it is less than 70% that we remember. We've already lost over 30%. And that just continues until a week later, where roughly we remember about 40% of what we learned a week ago. We've lost 60% already just in that 1 week. So going back to the information is really helpful, because that research continued shows us that not only do we remember more of it because we revisited information. So if we learn something to 100% on one day, the next day, if we revisit it and go back to that understanding of 100%, from that 80% we relearn that 20% that helps us remember. Now it's going to take us 2 days to lose the same amount of information, to lose that retention, to retain only that 80%. So, and then if we learn it again, then it's going to take us 3 days to lose that information. So the fact that we are revisiting that means that we are remembering more because we're revisiting it, but also we are not losing the information in our brains as fast. It makes complete sense that our brain makes room for new things as what's important, but if we're trying to learn something and remember it, revisiting it means that we are able to remember it for longer and more effectively. So this is why we're reviewing already. So first, we're going to go over the highlights of what we've covered so far. So lesson 1 was the components of soil, water, and air. and we looked at how soil is made up of air, water, minerals, and organic materials. The mineral composition of the sand, the silt, the clay, how much of those grains are in the soil affects the porosity. So how easily water is retained or held onto in the soil. I think I'm saying porosity wrong. I think it's porous. I don't know. Anyway, it's bothering me. I got to look that up again. Okay, water we looked at, and we talked about how water is a universal solvent. So it dissolves many things. Most things that are polar, it is able to dissolve. And so that affects the water cycle and how acids and bases work. So then we looked at the water cycle and how our water is cycled, how it moves throughout our environment, through the atmosphere, through lakes and rivers, through soil, and how then it goes back again and again. Then we talked about how acids and bases and how solutions that are more acidic or more basic and on the pH scale, so acids having lower values between 7 and 0, and bases having higher values between 7 and 14, how that has an impact on the environment around them. So if things become more acidic or more basic than they were before, then that has an impact on the nutrients in the soil or in the water, and then also in terms of the plants and animals that can thrive and survive in those climates, because of if their environment changes and becomes more acidic and or more basic, then they aren't unable to get the nutrients that they need and could be harmed. And then we talk about air and how it's made up of various gases. Specifically, we looked at carbon, oxygen, and nitrogen, and how this is cycled through and used for the rest of our ecosystems. So hopefully within you're able to cover all of these success criteria that we did within this lesson. So lesson 2, we looked at the highlights, the effects of human activity on soil, water, and air. So soil, we looked at how deforestation, urbanization, erosion, chemical fertilizers and pesticides, and industrial chemicals all destroy the soils. So these are all the results of human activities or the result of human activities that means that we've polluted the soil. And we talked about how this degrades the nutrient value within the soil and washes soil away potentially, and how that then has a effect on the development and growth of plants. Then we looked at water and how recreational, industrial, and everyday human activities can pollute the water. And we talked about how the water is cycled through our systems. So if we are adding pollutants, then we are making water more acidic often, and then that gets cycled through. So then we just talked about how if water is more acidic, then this has an impact on the growth and health of plants and animals. And we talked about air and how burning of fossil fuels leads to air pollution and the greenhouse gas effect, which then we talked about the climate crisis results in the detrimental effects on both humans and the natural world. So the fact that we are burning fossil fuels and adding those elements into our atmosphere, and that's creating the greenhouse effect and increasing the temperature of the earth, and that's having a domino effect of disastrous consequences. So our success criteria are such that we are comfortable with all of these topics. Hopefully you are. Okay, so then lesson 3, the highlights on sampling, monitoring, and monitoring quality over time. So how do we actually measure those impacts that we just talked about as having? How do we know that we're actually having these impacts? What are the methods to measure and check on the quality of our air, soil, and water? So first we looked at soil and we looked at core soil testing. So how when you take a deep sample of the soil, so instead of taking a wide sample and covering a lot of area that damages the soil, but also means that you're really only getting information about that surface level, the first few inches maybe, taking a core soil sample means that you are digging deep down and getting through the various layers of the soil to figure out the impact and the health of the whole richness, the depth of the soil. So we looked at soil profiles to see what the various layers of soil are and how they're different and how that needs to all be measured. Then we looked at water and we talked about water sampling and testing. So how we watched a video about an integrated water sample, which again takes a long, deep sample instead of just taking a surface level sample. Using a long tube means that you are able to get information about all the water, both the deep water and the surface level water. And then you can measure the various contaminants or nutrients that are in the water. We then talked about boil water advisories and how in Canada and Ontario that many of the places that have boil water advisories are Indigenous communities and how this is problematic and a part of an injustice, climate injustice and environmental injustice, as it doesn't make sense why these communities are struggling with clean water when white communities or non-Indigenous communities that can be very close to them have water, the water treatment is fine. We tried to look at a map that had detailed information, but it wasn't working that day. I have since checked it and you can go to Water Today and look at that map a little bit more in detail if you'd like. And then we looked at air and we talked about stack sampling. So how most of the pollutants that are being put, or many of the pollutants that are being put into the air come from factories that have these big tall stacks that are emitting pollutants. And so we sample right at the source, right at the inside the stacks before you even get into the air, because gases disperse really, really quickly and easily. So then we're able to measure the toxins and the emissions that are being put into the air fairly straightforwardly. So then we talked about the air quality index, which is the impact of what happens when the pollutants are in the air and how concerning that is, and where in the world there are more, have higher risk of not good air quality. So again, hopefully you are comfortable with these success criteria and you are feeling as though you are good with lesson number 3. And that wrapped up unit 1. And so now we've have the first 2 lessons of unit 2. So unit 2 in lesson 4, we talked about the cycling of substances in ecosystems. So first we defined ecosystems and we looked at both the non-living elements, which are things like water, soil, and air. Those are sunlight, temperature, all those things are part of ecosystems and they're non-living. And then the living elements, which are the plants and animals. And we talked about specifically how there are producers, consumers, and decomposers, and how they work together to cycle the nutrients throughout a healthy ecosystem. So producers being the ones who are able to create their own food and energy from the non-living elements, from the sunlight, from water, from soil. And then consumers are not able to make their own food and energy and they need to consume. So either they consume producers, eat plants, animals that eat plants, or they consume other consumers, other animals who consume other animals. And then we talked about decomposers, which are the bacteria and fungi and like worms and insects, things that decompose the waste and the dead organic matter, which then returns the nutrients back into the soil, which means that or releases them into the air, which means that the producers can then use them again to create energy and grow. So that's how it cycles in a natural ecosystem and a healthy ecosystem. Then we also talked about how human activity sort of replicates similar ecosystems, not quite, and definitely not healthy, where we don't have any producers, we aren't able to create anything on our own as humans, but we do extract from the earth. So we take from the earth, take from the producers, and then we consume. We're really good at consuming. We consume both in terms of eating plants and animals, but also we consume other elements and make products that we then use. But then we are very bad at decomposing. So we are not good at returning things back to the soil, back to nutrients, back to the cycle, so that they're able to be reused again over time. We generally just create waste and pollution. So we talked about the interconnected cycles of that make these ecosystems thrive. So we looked at oxygen, carbon, nitrogen, phosphorus, and sulfur as the cycles where the producers, consumers, and decomposers are able to use all of these elements, and how they then, once they use them, how they return or how they're used by the next stage of an ecosystem. And just to show how interconnected and how important this is for those systems, and how we didn't talk about it directly, but sort of implied about how humans disrupt those cycles, and that has an impact on the ecosystems. So then we talked about biosolids and how, what they are and how they're treated, and how this is one way that humans are trying to become better decomposers. So by processing and treating our waste, how that, and then returning that to the soil, means that we are returning these nutrients to the soil that then can be reused, instead of just making them waste that becomes pollutants. So we watched some videos about how they are helpful and how that's really beneficial potentially. But then there are some concerns, and what those concerns are, to be informed members of society, opposed to just being like, great, this sounds like an awesome idea, no worries. And there are some things that are still being studied and need to be questioned. So again, hopefully these success criteria you are feeling comfortable with. If not, go back to lesson 4 and spend some more time there. And then finally, we looked at lesson 5 and the carbon footprints. So we talked about how carbon footprints are the measure of the amount of greenhouse gas emissions produced. And we did personal reflection in terms of our own emissions, as well as possibly our communities or our countries. Then we talked about the inequities of carbon footprints globally, and how the white minority creates the most emissions. So people in wealthy countries, or in countries that have thrived through colonization, basically. So like Canada, United States, many European countries, Australia, New Zealand, Japan, these countries, though, are not necessarily all 100% white communities, white countries, but they are the ones that are creating the most emissions. Whereas the global majority, which are generally the Black, brown people, Indigenous people, are the ones who are being the most impacted by greenhouse gases, and though they are not the ones who are contributing to the problem. And then we did not have time to look at the reducing carbon footprints. We ran out of time. So we wanted to look at individual impact and structural change. And so we're going to spend a little bit of time today watching some videos and reflecting upon that a little bit, because we weren't able to get that in the last lesson. So again, the success criteria are that you're comfortable explaining carbon footprints and climate injustices. And then hopefully, once we go through these couple of videos, you'll be comfortable talking about how carbon footprints can be reduced. So before we dive too much more into our Throwback Thursday, let's look at those carbon footprints and how we can reduce them. So we've got 2 videos that we weren't able to watch in our last class. And so these just sort of help us understand what it is that we're able to do to actually change the impact that we're having on the earth.
They're not too long, and then we'll still have time to do a little bit more review of all of the lessons.
In first grade, above the cubbies where we kept our snow boots and mittens, big Comic Sans letters spelled out "Remember to recycle" and "Last one out turns off the light." These are the kinds of things recommended by science textbooks, blogs, and even the US Environmental Protection Agency as ways to reduce your personal impact on the climate. And they're pretty easy to do. On average, in the US, turning off the lights when you aren't in a room can save about 1/3 a kilogram of carbon dioxide per day. Using a reusable shopping bag every time you go to the store saves 5 kilograms a year. Drying clothes on a line instead of in a dryer saves around 200 kilograms per year. But compare that to the average carbon footprint of a person in the US. 16.5 tons a year. Tons! So what can you actually do to make a meaningful difference? Living car-free keeps 2.4 tons of carbon dioxide out of the atmosphere every year. But getting rid of your car maybe isn't feasible. People in rural or suburban areas have to drive more, but that's a big part of why they produce double the per capita emissions compared to people in urban areas. Driving an electric car can save about a ton of carbon dioxide a year, but that still doesn't have as much of an impact as just not driving. That will require big changes in how we live. Getting rid of your car is technically an individual choice, but it really requires cultural change. That isn't easy, but we've done it before. I can both vote and wear pants now. It's pretty amazing that we're able to hop on a plane and get anywhere in the world in a day. But try turning your next big holiday into a staycation. You could avoid up to 2.8 tons of carbon emissions by skipping that flight. But until we invent teleportation, flying is really the only fast way to travel long distances to see family and do business stuff. There's really no practical way to fly that doesn't put hundreds of kilograms of carbon dioxide into the atmosphere. Globally, raising livestock is on par with transportation when it comes to greenhouse gases. But you and your neighbors are eating about 20% less beef than you were 15 years ago. That's kept 185 million tons of carbon dioxide out of the atmosphere. And today, 1 in 16 people in the United States say that they are vegan or eat plant-based diets. If you cut meat out of your diet, that's 800 kilograms of carbon dioxide kept out of the atmosphere every year. The choices you make about what you eat are ways to impact the climate every day. Quick recap. Get rid of your car, save 2.4 tons. Fly less, save up to 2.8 tons per trip. Stop eating meat, probably reduce your emissions by around a ton. But here's a really tough one. If you choose to have 1 fewer child, that saves on average 60 tons of carbon dioxide per year. This is far and away the most effective thing you or I or anyone in the developed world could do to reduce our emissions. I'm definitely not gonna stand here and tell you not to have children. Family planning is a family thing. And fewer kids is already the trend in most nations. As a population gets healthier and more educated, birth rates drop as a rule. These are all huge life changes that don't always come easy. There's a lot of culture wrapped up in what we eat, how we get around, and what our families look like. Here's a choice that's a little simpler. In a lot of places, families can choose to buy green energy that doesn't contribute to more emissions. This is surprisingly easy. For me, all I had to do was log into my account with my energy provider and select the renewables box. Now I get a monthly email telling me how much carbon dioxide I didn't put in the atmosphere. In some places, this may up your energy bill, but if you got some extra change lying around, I highly recommend throwing it at solar panels. But don't actually throw it at solar panels. From small and easy things like reusing shopping bags and turning out the lights to those more challenging, high-impact lifestyle choices like what we eat and how we travel. We all have real power to change our culture and respond to climate change in a meaningful way. Solving this isn't going to be up to any one of us. It'll be up to all of us.
Thanks for watching Hot Mess. If you like what you see, please head over to our Patreon page. Your support will help us make.
So that was a really good video that shows the complexity of these issues in terms of, yes, we can turn off lights and use reusable bags, totally, and that's great, but that those of us who live in northern communities, who live in Sioux Lookout, we, in order for our food to get to us, that means that that needs transport. In order to have access to services, we need to travel. And those are things that we aren't necessarily able to change because structurally, our society hasn't set it up for us to be able to not do those things in order to survive. So it's more complicated than just turning off your lights and reusing bags, though those are totally good things to do. So then this next video that I wanted us to watch talks about structural versus individual change. That video talked a lot about what you can do individually, which are totally good things to choose. One thing I wanted to mention was how when they're talking about eating less meat, I think to me that seems about like commercially farmed meat. So if you are hunting and eating and fishing and eating things that are naturally, like that you're able to catch yourselves and aren't farmed or mass produced, I feel like that has a different emission because you're not contributing to that cycle of those mass productions, which is where the emissions a lot happen. Just an interesting thing to consider. Anyway, so now we're going to watch a video about structural versus individual change, because a lot of those suggestions were about individual change, and again, it's more complicated than
that in terms of what you can just do by yourself.
So the other week I got invited to a party. Great party. I'm gonna get down like it's not even Anthropocene. God, who invited Climate Adam? He always steals all the ice to do his climate experiments. So, you got any ice? What? No. Worst party ever. So what do you do when you're not asking strangers for ice? Well, I'm actually a doctor in climate science, but now I'm like this big-time climate change celebrity. Imagine if Leonardo DiCaprio was even more sexier. I think about climate change all the time. It just feels like we're not doing nearly enough. But I feel so helpless. It's such a huge problem. It doesn't feel like cutting my own emissions would make any difference at all. So what's the point in doing anything? Well, if everyone said that, then no one would ever do anything. But no one is doing anything. But look, every little helps. Given how big the problem is, I don't think that's true. Well, I mean...
Hey, what are we talking about?
She looks weirdly different. Great. Miriam is like an expert in environmental behaviour. So, Miriam, back me up. Isn't it crucial that we all do our bit to cut our emissions?
Well, no.
Exactly. So, just like I was saying... Wait, what did you say?
What we need is systemic change. We need to focus on the bigger players. You're just focusing on individual action because you want to feel good. It's kind of vain.
That is an outrageous accusation.
Look, our lives still depend so much on fossil fuels. There's no reasonable way to cut our dependence on them without completely changing the system.
Okay, maybe we as individuals can't make all the cuts to greenhouse gas emissions, but that doesn't mean we can't make a huge difference.
But ultimately, just 3 countries account for 50% of all global emissions. We need to be focusing on stopping the big emitters.
But those countries are made up of individuals, and they're producing products that are used by individuals. I mean, we're all using them, so we're the ones that need to cut down.
Maybe some individual action can change some stuff, but plenty of things require systematic structural change. If I wanted my city to only use electric garbage trucks, for example, that needs government action. I can't do it myself, unless I become, like, the electric garbage truck kingpin of New York. It's not a bad idea. Should write that down.
Okay, well, if you think individual action is so silly, then I guess you fly all the time?
No, I try not to fly that much.
And you eat loads of red meat?
No, not exactly.
And doesn't that individual action have some structural effect?
Well, I guess vegetarianism and veganism have become a little bit more common over the last couple decades as people are picking and choosing what they put on their plates.
Mm-hmm.
But what about you? Is all you do for the planet not flying, avoiding certain things, turning off your lights?
Well, no, of course not. I mean, I go on protest, I write to my elected officials demanding tough climate action, I try to start climate convos. I see what you're saying, actually.
So it's possible that fighting over whether individual or structural changes fight climate change better is maybe missing the point. And I guess individual actions where people have the means and are able to do them can help push for global change.
And structural changes can help us take individual actions that make a positive difference. And with global carbon emissions still rising, if we're going to limit global warming to anything remotely safe, we need all the actions we can get. Structural and individual. Okay, but what should we actually do?
Well, vote. Vote early, vote often, vote for climate-friendly candidates.
And reuse and repair your stuff as much as possible, whether that's your clothes, your phone, whatever.
Plus, help raise funds for community solar or other local projects.
Ooh, also avoiding flying and driving when you can.
And help out on a political or a policy campaign.
Try to eat a little bit less red meat and dairy. Whoa, this sounds like a lot. No, wait.
You just need to start somewhere.
Just pick 1 or 2 things that work for you right now.
So long as you vote.
Okay, I guess I can manage that. Okay, who here ordered 20 kilos of ice? Thanks for watching, and a huge thanks to Miriam. It was so much fun making this video with her. You can check out her channel.
Alright, so that is
overall look at why it's more than just structure, or it's more than just individual change. So it is really important to do things to make change, but it's also important to advocate, to act, to do activism, to vote for people who are being aware of these issues and wanting to deal with these issues. Those are the individual actions also that have a bigger, more widespread effect. So again, individual actions add up, but structural change is what we really need to make a difference. So we need both, but structural change is what's going to change things in the long run. All right, so that gets us caught up on the end of lesson 5. So now we can spend a few minutes looking at the connections across all of the lessons. So we're just going to look through a few of the key questions that I'm not going to answer them. I'm not going to write them out, but just we can discuss them a little bit in order to set you up for success for submitting your work. So the first set of questions is on page 6, the check your understanding questions 1 through 3, and they are talking about soil and water. They really are fairly straightforward questions in terms of why porosity is important to good soil, why water is a universal solvent, and the difference between groundwater and surface water. We went into all of these in fairly extensive detail in that lesson. And then questions 1 through 2 on page 7, when we're talking about air, living things needing oxygen. And so when we're breathing air, talking about, are we mostly breathing oxygen? That one, in theory, you could answer yes or no. I would strongly encourage you to write more than just yes or no. That does not give me very much information. And then how do living things take in nitrogen for survival? How does that work? Then there review questions on page 9, questions 1 through 12, looking through these questions. So you get to choose a little bit. So number 1, describe characteristics for each of the 3 environmental spheres. So give me information about soil, land, and water. Then provide an example of how the components of one environmental sphere can be mixed into a different environmental sphere. So how are they interconnected? Number 3, do you think one environmental sphere is more important than the other 2 spheres? Support your opinion with 2 or more supporting statements. So this one, there's not a right and a wrong answer. So it's not a matter of what I think, it's a matter of what you think, and you need to back up, you need to justify why you think that. So I could get 3 different students giving me 3 completely different answers, but as long as you back up, you support why you believe that, then you can get full marks. Using the circle below, create a pie chart illustrating the composition of soil. You do not need to make this precise. I'm not evaluating you in terms of your ability to make a pie chart, giving me rough approximations and labeling them so that it makes sense and is logical is totally fine. So then continuing through, again, the rest of these questions that are talking about just the composition of soil, water, and air. Okay, so then moving on to lesson 2, check your understanding page 12, 1 through 4. So then we're talking about, these questions are now talking about the impact of humans on the soil, water, and air. Sorry, continuing on page 15, you check your understanding questions. And then the review questions on page 17, 1 through 11. Again, going through these questions, you'll see that they really cover all of the topics, but that we should have really covered between reading the workbook chapters and going through the lessons. Then we have talked about most of these things. Some of them, like question 5, identify and explain one potential human impact on a salmon spawning stream if a new housing development was built nearby. We did not talk about that specifically, but you can infer in terms of what are the environmental impacts when new construction is happening. How is that going to affect the water and the salmon in a stream? So these answers aren't necessarily things that you need to look. Some of them might be things that you can directly look up and say, like, describe 2 ways human activities can cause topsoil to be damaged. You can kind of look that up in our lessons and see exactly the answer to that. But some of them you're going to have to be a little bit more interpretive, and you're going to have to understand the concepts. Then lesson 3, check your understanding on page 19, 1 through 3. What is a soil horizon? The difference between A horizon and B horizon soil, and the core sample. So this is all talking about how soil is tested, which we went through fairly in depth. And on page 22, question 1 through 3, again, looking at the water testing, and we answered all of these questions in our lesson 3 conversation. Then looking at the review questions on page 27, 1 through 11. So again, we're talking about how to measure the health of soil and the health of water and the air quality index. Remember that what's written in your book in the air quality index is slightly different than what I showed. But it shouldn't affect the questions specifically. Those numbers aren't really super relevant to these questions in terms of, like, why would people with asthma and other respiratory problems have to wear a breathing mask or stay inside if there was more fine particle matter in the atmosphere? It doesn't matter what level we're talking about, but just talking about that in general. Even this question number 11 that says an air quality index of 120 has been reported. Describe 3 actions you could perform that day to help reduce smog. So it doesn't matter what that number is in terms of 120, just how could you reduce smog is really what the importance of the question is. Okay, so then check your understanding on page 34, question 1 and 2. So now we are moving into ecosystems, and what are the 2 uses of biosolids, and what are the different ways that you can dispose of biosolids. So we talked about this again in our lesson. And then the review questions on page 35, 1 through 6. So this lesson has not as many questions. Again, talking mostly about biosolids. Is that something that we are moving forward with, and is the way that we currently are able to reduce our impact on ecosystems? But then again, defining a bit of ecosystems and understanding what it is or how they work in the natural world. Then moving into lesson 5, page 37, the check your understanding questions 1 and 2. So what is the difference between a carbon sink and a carbon source? So this is talking about in terms of forests, remember? And then talks about carbon dioxide equivalents and what does that represent? What does that really mean? And then on page 38, check your understanding number 1. Identify 3 activities that contribute to your primary carbon footprint and 3 activities that contribute to your secondary carbon footprint. So again, this is going to be a personal question. It is not going to be the same for everyone. There might be some similarities, but it's totally okay to do it's a personal response. So what makes sense for you is fine if that's different than somebody else. And then on page 40, the questions 1 and 2, talking about how lower carbon footprints you can have those with a hybrid vehicle, And 3 activities that contribute to Canadians having a larger carbon footprint than Egyptians is the example that they give, which just feels a little strange to be specifying. But in terms of what are we doing differently in Canada than in other countries in the world, that means that we have a larger carbon footprint. And then finally, the review questions on page 43, 1 through 12, are again all talking about carbon footprints and the impacts, and then as well as the ways to reduce your carbon footprints, both personally, but then remember that piece about the structural change and about how do you have an impact individually on the structural change. Right, and that's all of what we've covered so far in the past lessons, so lessons 1 through 5. There has been a lot already, but hopefully with a bit of a review today helps you remember them. If you have any questions or want to discuss any of the key questions, please feel to contact me. My number at the office is 807-737-1488, extension 2209. And you can also call us toll free at 1-800-667-3703. You can email me at bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca, or you can connect with me through Facebook at bslatewahsa. Remember, all of our lessons are uploaded to YouTube after airing, and with this lesson, I will link all of the previous lessons as well in the show notes. So if there's any area that you're not quite sure about, going back to those previous lessons is going to help you out in terms of understanding all of this material. My office hours are Monday through Friday, 8 a.m. till 2 p.m. So feel free to reach out to me within those hours, and then I can get back to you if I miss you. If you can't connect with me and you do have questions and you'd like to talk to me directly, we can set up a time outside those hours if need be to actually chat. Thank you so much. I hope you have a lovely weekend, and we will be back again on Monday. Miigwech.